When I taught you trig last week, I went ahead and used a rule that I'm going to teach you today. So I went ahead and taught you the complete trig rule, not just a little bit and then a little bit more. But what we're going to look at today has several names. It's called the chain rule, which is like the big umbrella. That involved even what I did with y'all the other day. But under the chain rule, there's a thing called the power rule. And really, that's what I'm going to teach today, is one part of the chain rule. The chain rule is an umbrella that covers a couple different things, and within it is this wonderful thing called the power rule. Okay? Now, I'm going to show you when to use it, and I'm going to show you how to use it. Y equals parentheses, 4x squared plus 1 raised to the 5th. All right? You could write that out 5 times and use the product rule a long time. We're not doing that. What you do, and this is how, this is one of those things where I'm not proving the rule. Let them do that in the AP class. Bring the 5 to the front. Subtract 1 from the power. And then take the derivative of what's inside the parentheses and write it out here on the end. That is the power rule for getting instantaneous rates of change. And dy over dx would equal 40x, parentheses, 4x squared plus 1 to the 4th. It is that easy. Okay? Do another example. Y equals square root 6x minus 1. Y equals 6x minus 1 to the 1/2. dy over dx equals 1/2 6x minus 1. Subtract 1 is a negative 1/2 when you subtract 1. Is that okay? And don't forget to put what out here on the end? The derivative of 6x minus 1. Okay. And that's how the power rule works. Really nice and simple. If you wanted to, if you're going to take the derivative, you have u raised to some power, right? Is that okay? Then what do you get? You get the power, u, power minus 1, but what do you have to remember to put out there on the end? The du. Okay? And that's the power rule written like so. So far, so good? Don't get in a big hurry, Mr. Evans. Slow Monday. Right, now we'll write out the formal definition of the chain rule. And you'll see how the power rule fits in. What the chain rule says is that you have a function inside of a function. Like if you think about it, you had the square root function, and inside that square root function you had that other function. Okay? All right? You have a function inside of a function. So, you have y equals a function of another function. You have that outer function of another function. Chain rule says that dy over dx will be the derivative of the outer function times the derivative of the inner function. All right? And that's the formal definition of the chain rule. You have a function of a smaller function or another function, and you take the derivative of the outer times what? Derivative of the inner. All right? I am not going to do it as these multiple steps. I want you to do it all one time. One step. All right? Now, here's what happened yesterday when or last week when we were doing the derivative of trig functions. the sine was your f function. Is that okay? And this was your what? G function. But it wasn't f times g, it was what? F of g. All right? In other words, f of x equals sine x, g of x equals 4x squared, and you really had, oh, I'm going to write it underneath even though I don't want to, y equals f of g of x. I went ahead and taught you the chain rule for trig without even calling it the chain rule, so that you can get the information. So it would be f prime g of x times g prime of x. So it would be cosine 4x squared, took the derivative sine part, and then 8x out. Is that cool? So you were using the chain rule last week and you didn't even know it. And really, today we're looking at the power rule, which is just one specific part. Make sure you got this written down somewhere. All right, put a little circle around it, put stars by it, because we're going to talk about this definition and we're going to use it for a few things. All right, now, I want to show you a little way to make the chain rule your friend, or power rule your friend. Here we go. I have y equals 1 over 3x plus 1. And then we're going to talk about what would you do if y equals x over 3x plus 1. So two separate problems, but they look very close to the same thing. It's just one only has a constant in the numerator, and one has a variable in the numerator. All right? I'm going to show you something that works really nice if you only have a constant in the numerator. Don't do this if you have a variable in the numerator. But with a constant in the numerator, go ahead and rewrite that as 3x plus 1 raised to the negative 1. And use your power rule. Subtract 1, take care of that, get 3. That is a nice little shortcut for avoiding the quotient rule as long as you only have what in the numerator? Constant. If you try to do this with that over there, you're going to have a bad day. So, here, you better stick with the good old quotient rule. Derivative of the x is 1 minus the x times derivative of 3. All right? And make sure that you've got that written on your page so you'll know when you can use that little shortcut of the power rule and when you don't want to use that little shortcut of the power rule. Now, so far so good? Let's look at the trig functions for just a second and talk about the little 2 written here. Sine squared 3x, right? Sine squared 3x. I'm going to rewrite that. Because that's what it means when it has that square. That square there means you would take the sine of the 3x and then you would square the results. All right? So this 2 there, that square means all of this in parentheses what? Square. Is that okay? So, you're looking at a big power rule. You got all that stuff in parentheses with a power above it. You're looking at a big power rule. So dy over dx, bring the 2, write down your sign of 3x, and do you have to really put a 1 up there that's a power of 1? No, but guess what I'm going to do? I'm going to put a 1 up there so you know that I subtracted 1. But then what do I have to do to this whole thing in parentheses? I have to use my derivative of a trig function. Notice all the rules that you're supposed to already know are coming back. And what's the derivative of sine 3x? It's what? Cosine 3x times another what? 3. And that's really a function inside of a function inside of another function. Okay, I'm going to get rid of that 1 there. Probably get rid of that set of parentheses and look prettier too. But do you realize when you see a power in here, it's like it's all in parentheses with the power out there? See what I'm getting at there? All right? And that's important. Someone says, but Mr. Evans, I looked in the back of the book and that's not the answer. Or that's not the derivative that's in the back of the book. Try to avoid using the word just answer. What is it? It's derivative. That's not the formula that I saw in the back of the book. Anyone? Want to take a guess on what was written in the back of the book? Two sine theta cosine theta equals sine of what? 2 theta. It's that trig identity last year that I told you to put stars by. You're going to see it a lot, so get used to it. I'll be honest, if you left it like this and I asked you what is the slope at x equals pi, you could put a pi in here, and work it out, right? But that's what it's going to simplify down to. So far, so good. Doing lots of examples, because that's the best way for you to learn this. It's for me to work lots of examples for you. All right. Y equals square root of tangent x. And if you wrote a power of a 1/2 right there, that'd be okay too, wouldn't it? Yeah. You put tangent with a little 1/2 power right in there. Be right there. Everybody, but I think y'all probably won't do this. What am I trying to get you to see? I'm trying to get you to see a power rule. Okay. 1/2 to the front, subtract 1/2 from the power, and please don't forget to take the derivative of what's right here inside the parentheses. It's got to go on the end. du. That's what people forget is the what? du. Okay. All right. Now, go ahead and talk about the hard algebra problem. Oh, and okay, you see that problem? I've got to write this. Sine y equals sine 3x squared 3x squared. Y'all realize this and this are not the same thing, right? Yeah. This would just be dy over dx equals cosine 3x squared times what? 6x. Notice they are different. Where you put that 2 matters. For those of you that write all your little 2's and 3's so small that you can't see them, you're going to have problems. Man in the middle is like, he's talking about me. Yeah. All right. I'm trying to guide you down the road just because I've been there before. Pushing this rock up the mountain so it can roll back down before 5th hour. All right, here we go. Y equals, parentheses, 3x squared plus 1 to the third times 4x minus 2 to the 5th. Now, this is the bad boy of the day. This is the one that's going to make you do some algebra when you're finished. But before we get to there, let's put the little dot right here. First function, there's your f, there's your first function, and there's your what? Second. Does everybody realize, though, when you take the derivative of that first function, you're going to have to use a power rule. And then when you get ready to take the derivative of the second function, you're going to have to use a what? Power rule. All right? So, let's see if we can do that. Dy over dx, dy over dx equals, bring the 3 to the front, write down your 3x squared plus 1, subtract the power, and then don't forget to write what out here? 6x. That's just the derivative of the first part. Is that good? Then you know you have to write down what? The second term. Plus, okay, so there's your first term's derivative. There's your second term. Now we're going to write down the first term. Raised to the third. And then we're going to take the derivative of this second term, and we're going to use our power rule to take the derivative of that. So we get 5. Please do not change the order we're doing this in. 4, and then take the derivative of that, which is what? Take a 4. No, I do not want you bringing that 4 to the front in the same step. You put it out there on the end so that you know you did your du. All right? I am lazy. That is the reason I am stuck here in front of you forevermore. I'm lazy. Path of least resistance got me here. You can't do less than what I do. All right? Yeah. I'm showing you the least amount of work and still get it to work. All right. So, F, and there's your G prime. Now, before we do any algebra, let's talk about the derivative and see if there's any question. I want you to tell me if there's any part of this you need me to explain. Because this is a serious problem. Anyone? Front row. Back row, just go back to sleep. All right. Anyone? Happy? We're all happy. Okay. I'm about to teach you how to do the algebra. When you do the algebra for this, line up your plus signs. Line up the plus signs and put your bracket up here and put your bracket back here. All right? Line up the plus signs. Now, see this 3x squared, don't worry about the 3, the 6x. Let's get the big parts out first. See that 3x squared plus 1 squared? See that 3x squared plus 1 cubed? We're going to factor out 3x squared plus 1, and we always factor it out to the lowest power, which is a what? Squared. That way, that one factors out and just leaves a 1, which I'm not writing down. This one factors out and leaves 3x squared plus 1 to what power? Power of what? 1. Everybody say it. We always factor out to the lowest power. We always factor out to the, lowest power. So when I factor out the 4x minus 2, what power of that am I going to factor out? 4. And that's going to take care of this one and leave just a 1. This one's going to leave 4x minus 2 the first. Now, once you get rid of that, you can start worrying about these other parts. I got a 4 here, and I got a 6 here. Does everybody agree I can factor 2 out of both of those? Is that okay? So we'll do that. Now we'll put it here. So that's going to leave 9x, and that's going to leave 10. And we're going to write the front down, 2 parentheses, 3x squared plus 1 squared, parentheses, 4x minus 2 to the 4th. And then that bracket, if you wanted to, you could multiply all this out, right? Okay? You get 36x squared minus 18x plus 30x squared plus 10. And then, oh, I hate writing all this down, but I'm going to. And that would just become what? 66x squared minus 18x plus 10. And I'm thinking I lost something else that I could have factored out along the way. Oh, yeah, the 4x minus 2, I could have factored what out of that? 2. So you could factor another 2 out of that if you really wanted to, right? Everybody okay? You can factor another 2 out of that? Now, notice how that simplified down to a trinomial that you could factor or use a quadratic formula and find out where it equals 0. Right? Notice you can find out where this equals 0. This one doesn't ever equal 0 because that's going to be a positive. And if you add a positive, you can't get 0, right? But you could set this part equal to 0, and you could set this part equal to 0. And why is 0 important? Because that's where we could have the change in direction of the particle. Or, if we had a particle going up and down, you know, for it to change directions, you have to have a point where the derivative equals what? 0. The reason this is so important to be able to factor this is this is what you'll have to use in the applications to get to the answers. All right? Notice the algebra is what I'm really teaching today. Is that all right? I'm waiting for someone to shake their head and ask me a question. No one's going to ask a question? Oh, no, I don't want to look bad. Mr. Evans will yell at me. Have I yelled at anyone yet this year? Have I threatened to throw anyone out the window? You know, this is just... I'm just worried about someone that seeing these videos and going, I can't believe he's teaching them this simple approach to calculus instead of writing a bunch of gobbledygook on the board and then show them this. You know, we'll go back and talk about all those proofs after you learn how to do it. All right, here we go. Time to have fun. I'm setting you up on this one to make a mistake. Y equals 6x plus 1, 1/2, and x cubed plus 1 to the 1/3. Fractional exponents. You change those to decimals, you're going to have a bad day. Remember last year I kept telling you don't change anything to a decimal, right? Don't do that. Bad. Now, let's see if we can at least get the derivative out of this. All right, what are you going to do first? You got to take the derivative of the first part, right? Is that okay? So we're going to bring 1/2 to the front. Go write down what's in parentheses. We're going to subtract 1 from that. It's going to be what? Negative 1/2. Is everybody all right with that? 1/2 minus 1 is a negative 1/2. Take the derivative of that, we're going to get 6. Then we write down the second term. X cubed plus 1 to the 1/3. And we put our big plus sign. Oh, and the last problem, you realize now why I lined up those plus signs, because it makes it easy to put everything in the right place. Guy in the middle. What's your name in the middle? Mr.
Bradford.
Bradford. I can tell you Mr. Bradford didn't line up those plus signs, did he? Did you line up plus signs on the last problem? Oh yeah, I'm impressed, Mr. Bradford. You just, for some reason, you remind me of myself taking a class and not writing anything down, and just, you know, I don't want you to end up being a teacher stuck here in front of the class. All right. Notice I went through that one pretty fast. Let's see. I wrote down the first term. Okay, brought the 1/3 to the front. X cubed plus 1, and then I subtracted 1, which is what? Negative 2/3. Is that okay? And then I put what? 3x squared. Don't forget the du. How many of you got that without me explaining it? You were writing it just as you knew it? How many of you, yeah, how many of you can do that? All right. It's one of those things where the calculus is the easy part. Line up your plus signs. Put your brackets. Now, before I even start, someone says, Mr. Evans, 1/2 of 6 is just going to leave a what? 3, right? Yeah, we'll get to that. Let's not do that first. What are we going to do first? Let's look at what? 6x minus 1. All right? Now, what power of that are we going to factor out? We got a power of negative 1/2, and we got a power of 1/2. What did I just tell you the rule was? Lowest power. You better factor out the one that has a negative 1/2 above it. Lowest power. Watch what's going to happen. When you factor, do you agree you subtract the exponents? What's 1/2 minus a negative 1/2? 1/1. If you do this right, these parts that are in parentheses with the powers above them are always going to turn out to have a power of 1 above them, which makes them easy to work with. Now you see why I told you to repeat the rule. Always factor out to the what? The what? Lowest power. Okay, what are you going to do about the x cubed plus 1? What power? Negative 2/3. And that one's going to leave a 1. And then let's just see if it really works. X cubed plus 1. What's 1/3 minus a negative 2/3? 1. 1/3 minus a negative 2/3 is 1. So those end up with nice, pretty exponents. Then we can deal with the other stuff. That leaves a 3. And that leaves an x squared. 1/3 3x squared. Have I worked 2 of the same kind of example this year? This close to the same? No. Because this is something we've got to be able to do. All right, so then we write it down. We get 6x minus 1 to the negative 1/2 x cubed plus 1 to the negative 2/3. And then that should work out to be 9x cubed. 9x cubed, yeah. And then plus an x squared plus a 3. And there we go. And if you looked in the back of a textbook, these two would not be here, they would move those where? Down to the denominator, all right? Because that would make your undefined tangents. That's dy over dx. Okay. That's the hard type, right there. That's the hard type. Now, and I'll publish this as soon as the video's posted with it this afternoon, or I can go ahead and publish it now, and then y'all can just expect the video this afternoon. That's what I'll do. Go ahead and publish it, and then I'll just put the video on this afternoon.